simplify this radical, we see that the fraction inside the radical can be simplified, so we will do that first. 40 and 3, there's no common factor, so we will not reduce the 40 and the 3. X squared over x cubed gives us an x in the denominator, and y to the 5th over y to the 7th gives us y squared in the denominator. Now I can use the quotient rule to split this up into two separate radicals. I will factor both the top and the bottom, and to find our perfect squares. In the numerator, we know that 40 is the same as 4 times 10, with 4 being our perfect square. In the denominator, we already have it factored into perfect squares, so we are ready to move to the next step. The square root of 4 is 2. The square root of 10, that's not a perfect square, so in the numerator we have 2 square root 10. In the denominator, the square root of 3 and the square root of x, those are not perfect squares, so they remain under the radical. The square root of y squared is y, so I will bring that y out in front times the square root of 3x. Now you note that we have a square root in the denominator, which we do not want, so we will multiply by a form of 1, which is the square root of 3x over the square root of 3x. Now we multiply, and we will get 2 times the square root of 10 times 3x, which is 30x, all over y times the square root of 9x squared. I can go one step further on the denominator, and I can pull out the 9 and the x squared. This is 3x, so I will have 3xy in the denominator.